All right, today's lesson is 8.2. And everybody sees the warning, right? Everybody's okay with it? Nobody's going to get offended? All right, Crystal, you can leave the room when appropriate. All right. There are explicit graphics in here, so it's been rated M for mature audiences, and you're all pretty mature, so you should be able to handle it. Today we're going to solve a system of equations. Do you remember back in lesson 6 when we first learned how to graph an equation? Does that sound vaguely familiar? We put it into slope-intercept form, and then the second one, so we had something like this: y equals 2x plus 3. And the plus 3 would tell me to go up on the y-intercept, up on the y-axis 3, and then you drew the point. And then you counted for the slope up 2 and over 1. Does that sound familiar? Yes? I hope so. We're going to do the same thing today, except instead of doing just one line on the coordinate plane, you're going to do 2 lines. And then you're going to look to see where do those 2 lines intersect. Because now we're going to deal with a simultaneous system of equations. And there is one coordinate where the 2 lines intersect on the graph that will make both equations true at the same time. That's the coordinate we're interested in finding. Well, before we get to that, let me show you what it means to have that intersection point, making both of them true at the same time. My question is here to determine whether the ordered pair 3, 4 is a solution to this system. So we have a system here. How would we figure out if this is a solution to this system? What would we do with 3 and 4? Plug it in, substitute, and then see if we get a true statement at the end. So I'm going to plug in 3 for x and 4 for y. So when I do that to the first equation, I get 3 plus 4 equal to 7. Does 7 equal 7? Yes, so it works for that equation. But now, since it's a system, I also have to plug it into the bottom equation. 2 times 3 minus 4 equal to 10. That's 6 minus 4, which is 2. Is 2 equal to 10? No. So is this ordered pair a solution to that entire system? No. No, it doesn't work. That is not a solution to the system. So we're looking for the one coordinate that will make both of them true at the same time. Well, let's check this one, see if it works. We're going to plug in -1 for 6. I'm sorry, -1 for x and 6 for y. So we have in the top one, 2 times -1 plus 6. We want to know if that's equal to 4. 2 times -1 is -2. Plus 6 is 4. 4 is equal to 4. So it worked for the first one, correct? Correct. That one works. Now we'll try it with the second equation. In order for it to be a solution to the system, it has to work for both equations, not just one of them. All right, so I get -1 minus 6 equal to -7 for the second equation. -1 minus 6, that's -7. -7, yes, that's equal to -7, so it worked for both of them. So yes, -1, 6 is a solution. What that means is if I change both of these equations, the first one here and the second one, to slope-intercept form and graph them on the coordinate plane, the coordinate -1, 6, that's where they would cross. That's where the 2 lines would intersect. In this first one, what it means here is that if I graph these 2 lines, 3, 4 would be a coordinate on this first one right here, but it would not be a coordinate on the bottom equation because it wasn't a solution to both of them. All right, any questions so far? So now you know what it means to have an ordered pair that is a solution for an entire system. And it's an entire system being, what, just 2 equations. All right, here we get into the explicit graphics. And we're going to graph. That's what I meant by explicit graphics. We're actually going to graph some lines. I know, I'm sorry. Are you disappointed? No? Liar. Are you kidding me? The directions say graph right there. Okay. All right, we're going to solve this system graphically, then check your solution. How would you check the solution? By doing what? You'll get your ordered pair where the lines cross and do what with that ordered pair? Plug it back in, right? Just like we did on those first two. That would give us the solution. What? Okay. Now, this is the first way of like 3 or 4 different ways I will show you how to solve a system of equations. What you need to think to yourself, and if you can answer this question before the end of the period accurately, I'll give you some bonus points. Why this is going to be the most inaccurate way to solve a system of equations. You need to think about why. Why would this be? Graphing is the most inaccurate way to solve a system. Because we're learning this first. Because we have graphed before, and then I could give you a long explanation, but I don't want to, Julie. All right, the first one. Plus 4. We're in slope-intercept form, so I go ahead and graph them. Plus 4 means to go to where on the y-axis? Up 4. So I go up 1, 2, 3, 4. What's my slope here? -2, so that means down 2 over 1. Down 2 over 1. Okay, I can graph this line now. Oops. All right, now I'm going to graph the bottom one. I start at the origin and go where? Down 2, because that's -2. And then from there, what's my slope? Up 1 and over 1. Up 1 over 1. So, where do the two lines intersect? 0, 2, 2, 0. So what I want to do now, if I did have the right tool, I want to label my point of intersection. It's the coordinate 2, 0. The coordinate 2, 0, that's where the lines cross. If I plug 2, 0 back into here, I would get 2 true statements. All right, this one. Are they in slope-intercept form? Yes, so I can go ahead and graph them. The top one starts with a -1, which tells me to go down 1. And then what's my slope for that top one? 3 over 1. So that means up 3 over 1. Up 1, 2, 3 over 1. Okay, how about the bottom one? So that means to go where? Up 2. Up 3 and over 1. Does everybody see what's going to happen? What's that? Very good. Remember I said yesterday if you got good at this, you would look at these equations and say what? They have the same slope, so what's going to happen? They're parallel lines, so where are they going to intersect? They're not, so what's the answer? Empty set. Remember I mentioned yesterday, this could save you a lot of work if you were good at this. You could have looked at initially these two right here. You see that their slopes there and there are exactly the same. You could have parallel lines. Empty set. They will not intersect anywhere. There is no solution to that because they're parallel lines. I could go ahead and draw the line for you to see that. They'll never intersect. You have two parallel lines. So if you see that, if you recognize right away that you have two parallel lines there, you don't have to graph them. You can just put empty set, no answer. Now what would happen, just theoretically speaking, what would happen if the two equations were exactly the same? Let's say you had y equals 3x plus 4 and y equals 3x plus 4. You have the same line, but it's there are two lines there, right? It's just the same equation. So where are they going to intersect? The whole thing, everywhere, right? So what would be your answer? Infinity. There are an infinite number of intersection points, right? Because it's the same line just graphed on top of itself, so it intersects everywhere. So be careful of that. Watch for that. I think it happens more in our algebra textbook than here, but that is possible. Okay, this one. Can I go ahead and graph it? No? Why not? It's not in slope-intercept, so both of them have to be rearranged into slope-intercept form. So go ahead and do the top one. I need to x plus 3y equals 6. Subtract x from both sides. I get 3y equals negative x plus 6. Divide by 3. Now at this point I want to put my coefficient in here so that I make sure I have a fraction. What's my coefficient right here in front of x? What's this number? 1. Because when I divide by 3, now I have a slope. That cancels. I get y equals negative 1/3 x plus 2. All right, there's one of my equations. Let me get the bottom one. I get 3x plus 2y equals 4. Subtract 3x from both sides. Have you noticed I'm always moving x over first when I'm not in slope-intercept form? Okay. 2y equals negative 3x plus 4. Divide by 2. Y equals negative 3/2 x plus 2. Okay, now I can graph these two. Negative 3/2 x plus 2. Plus 2 tells me to go up 2 on the y-axis. A slope of negative 3/2 tells me to go where from that point? Where? Well, negative 3 on top tells me to go down 3, and then the 2 means to go 2 to the right. 1, 2, 3, down, 1, 2 to the right. 1, 2, 3, 1, 2. I could go up 1, 2, 3 and make the 2 negative by going the opposite direction. That's up to you. Graph my line. Okay, that is that line. Now I'm looking just for the intersection point, so I have to go back and graph that first one. Plus 2 tells me to go where? Up 2. Where's my intersection point? Right there. I already found it. Do I need to graph the line? No. What's the point of this? Define the intersection point. I mean, we found it without graphing the line. It's right there at 0, 2. I found it. So I'm done. I'll go ahead and graph it anyway just because. Negative 1/3 slope is down 1 and over 1, 2, 3. Or up 1 over 1, 2, 3. There. It's still at 0, 2 even with the line. So we found our solution just by graphing them. That's the one coordinate we're looking for in both cases. All right. Any questions?